Next, let us see how the LCS problem can be solved using dynamic programming. So our input to the LCS problem is two subsequences, x and y. X is of length m and y is of length n. And what we would like to do is write the algorithm LCS length that returns two tables, B and C. Now, it's important that we understand what the purpose of these two tables are. The table Cij, this matrix, contains entries such that Cij represents the length of the longest common subsequence so far. So Cij is the length of the LCS up to I and j. So here in the solution matrix, here the numbers that you see here are the Cij, contents of the Cij matrix. So here, this is our X matrix, this is our X sequence, and here's our Y sequence, B, D, C, A, B, A, and our X sequence A, B, C, B, D, A, B. And Cij is the length of the longest common subsequence to that point. Say, for example, if I were to look at the LCS between ABC and BDC, then my value in the C matrix is 2, which means that the longest common subsequence is 2. Here, essentially, BC is the longest common subsequence. So in this way, at any point of time, Cij maintains the length of the longest common subsequence. Now, what the matrix Bij represents is whether or not a given pair represents a part of the longest common subsequence. Now, this matrix Bij can contain one of the three possible values, either the up arrow or this kind of arrow or the left facing arrow. Now, what this table contains once again is these particular symbols, these symbols, upward tilted arrows, represent the pairs which serve as a part of the LCS. Now, looking at the diagram here, for example, this arrow here says that in this sequence X, this character C, and in this sequence Y, this character C are a part of the LCS. So now at the beginning, we initialize Ci0 to 0 and C0j to 0. In other words, we want to initialize the LCS between our input sequence X with 0 length Y as all zeros, and our LCS between any length of Y with 0 length of X also as 0. Now, following a bottom-up approach, we start with I equals 1 and j equals 1 and check if the two characters are same. If the two characters are same, then what we simply do is we add 1 to the current LCS that we have, that is the length of the LCS, to whatever the length of the current LCS that we have for the length I minus 1 and j minus 1. Let's take the example of I equals j equals 3. When I equals j equals 3, that means we are at this cell. Our x3 is C and y3 is also C. At this position, we have xi equals yj because C equals C. And the way we calculate Cij or C33 at this point is C22 plus 1. So C22, what we have is 1, and then we add 1 to it, and that's how we get this 2. And then we also set our matrix Bij to this tilted upward facing arrow, because this is one of the cases where we have xi equals yj, and then this represents the common character that is a part of the LCS. Also, if you remember, This is also the equation that expresses the recursive definition of the LCS problem. To consider the next scenario, say for example, I equals j equals 5. That is what we're looking at, is this cell right here. Then what we check is ci minus 1j is greater than or equals to cij minus 1. In other words, we are checking if C45 is more than or equals to C54. So C45 will be this number here 3, because this is C45 is more than or equals to 3 is more than or equals to C54, which is 2. So this is one of the cases where what we want to do is go up next step, or like go look for the next character in your sequence X. So here we set Cij. Our current ij will remain same as ci minus 1j. That is, in this case, C55 will maintain same as C45. So in this case, the highest of C45 and C54, this is 2, this is 3, and the maximum of these two is 3, and this will go into C55. Once again, this follows the recursive definition of obtaining the maximum between the two possible smaller values of ij combinations. The next possible scenario is the last else statement. And say, for example, when I equals 3 and j equals 4, what happens is we know that in this case ci minus 1j is less than cij minus 1. So in such a scenario, we want to set cij equals to cij minus 1. In other words, here we want to set C34 equals to C33, and C33 here is 2, which becomes now the also the longest common length. And we also want to set this arrow to this side, suggesting that we are now going to look at the next character in our sequence Y. So finally, in the bottom up fashion, we continue this for loop and continue this execution from the top left corner all the way to the bottom right corner. And at the end, we return these two matrices C and B as our solutions. Now, because these for loops run from run to m times n, the running time of this algorithm is big theta of m times n, where m is the length of our first subsequence x and n is the length of our second subsequence y. Now, to print the solution of LCS, that is to actually print the sequence B, C, B, A, we will need another function print LCS that takes one of the sequences, say x, our solution matrix B, and then I and j as the running lengths. So we call this function print LCS, passing the function bmn and also passing one of the sequences x, and then providing I and j as their maximum possible values. Now this is a recursive function where what we want to do is start from the bottom right corner and recursively navigate all the way to the beginning or all the way to the position where we started making the first comparison of xi and yj. So this is the recursive function where we start with I and j as their maximum values. We check if the solution has an upward facing arrow, tilted arrow like this. If we do find something like this, that means that we have found the first possible place where we have a character in the LCS. So then we call the same function again by moving it one position up and left. That is for a subsequence of length I minus 1 and j minus 1. And then we do print xi. So since this is recursive function and we keep calling print LCS with print LCS, the first character that will be printed is the first matching character, and as the recursion winds back down, it will print all the characters subsequently. Thomas Quest has actually posted a really interesting article on longest common subsequence. And he also has a visual that shows how the algorithm actually works to calculate longest common subsequence. So here's a GIF image that shows how the algorithm calculates the values of the two matrices C and B. If you are interested more in this topic of longest common subsequence, I encourage you to read this article and maybe even try some of the code that he has written.